Welcome, everyone. Today, we are diving into a crucial aspect of designing your overall AI strategy, determining exactly when your organization should invest in creating custom AI models versus leveraging pre-built solutions. Let us start by looking at the strategic decision context for AI adoption. When organizations accelerate their AI journeys, they face three primary pathways: build, buy, or extend. Buy means acquiring pre-built capabilities when time to value is the priority and processes are standard. Extend involves customizing platforms like Microsoft Copilot with specific domain knowledge. But our focus today is on the build pathway, creating AI components internally. Why would we choose this? You select the build path when your organization requires deep customization, complete control over data and intellectual property, and integration with highly proprietary systems. Evaluating this requires looking at your business drivers, such as whether the process provides a competitive differentiation or if it is merely a commodity workflow. This flowchart visualizes the high-level strategic decision context. On the left, we identify the business requirement. The decision branches into three paths: buy for standard processes, extend for hybrid needs, and build for unique, high-value workflows. As you can see, the build pathway leads directly to deep customization, IP control, and competitive advantage. By establishing this framework early, you avoid investing in custom development for commodity tasks, reserving your engineering capacity for solutions that truly differentiate your business. Before deciding to build a custom model, you must determine when pre-built or catalog models are actually sufficient. What are the basics here? Pre-built models from Microsoft Foundry or Azure OpenAI are ideal when your use case is general purpose. Think of tasks like standard document summarization, basic classification, or drafting routine emails. Why use them? Because they offer rapid time to value and low-risk deployment. If your agent interacts primarily with standard enterprise knowledge and does not require highly specialized reasoning, a pre-built model is often the right choice. You should only move to a custom model if these off-the-shelf options fail to meet your specific accuracy, domain, or compliance thresholds after tuning. Let us examine this mind map detailing when pre-built models are the appropriate choice. At the center, we have the pre-built model suitability. Branching out, you see the primary drivers: general-purpose tasks like summarization and drafting, environments with moderate accuracy requirements, and situations demanding rapid time to value. When your project aligns with these nodes, extending an existing Copilot or using catalog models is highly efficient. It requires less data preparation and operational overhead, allowing your team to deploy solutions quickly without bearing the high total cost of ownership associated with custom model training. Now, let us explore the first major trigger for building a custom model: domain-specific intelligence. What does this mean? If your AI system must understand highly specialized industry technical vocabulary, proprietary organizational processes, or unique linguistic structures, a general pre-trained model may lack the necessary accuracy. Why is this a mandatory trigger? Because in fields like healthcare, legal, or specialized manufacturing, AI must follow strict, domain-specific logic. How do we identify this need? Look for indicators such as highly specialized workflows, industry-specific compliance requirements, or tasks where proprietary knowledge dominates the performance. In these cases, custom models outperform standard copilots because they are explicitly trained on your unique domain language. This flowchart illustrates the transition from general language processing to domain-specific intelligence. On the left, a user query enters the system. If it flows to the top path, a general model attempts to process highly specialized jargon, often resulting in low confidence or inaccurate outputs. Conversely, the bottom path shows the query routed to a custom domain model. Because this model has been trained on proprietary enterprise knowledge and industry-specific terminology, it accurately interprets the nuanced query and delivers a high-precision, actionable response. This visual highlights exactly why specialized workflows demand custom AI architectures. The second primary reason to build a custom AI model is when off-the-shelf accuracy is simply insufficient. Basics, you might find that even after extensive prompt engineering, retrieval tuning, and fine-tuning attempts, a pre-built model still falls short. Why does this dictate a custom build? Because some business solutions require deterministic or near-deterministic outputs, and persistent low precision or recall can introduce severe risks. When the business cost of a wrong answer is exceptionally high, such as in automated financial approvals or medical triage, you cannot accept moderate accuracy. How do we assess this? By using structured evaluation metrics to identify persistent accuracy gaps that general foundation models cannot bridge, justifying the higher engineering investment of a custom model. Look at the sequence diagram mapping the evaluation process for model accuracy. It begins with the solution architect testing a pre-built model. The model returns results, but the evaluation pipeline detects persistent low precision and recall. The architect then attempts mitigation strategies, such as advanced prompt engineering and retrieval tuning, but the outputs remain below the acceptable threshold for mission-critical tasks. This documented failure pathway provides the empirical evidence required to justify the transition to developing a custom model, ensuring that the final solution can meet the strict deterministic requirements of the business. Our third crucial factor involves governance, compliance, and data sovereignty. What is the core issue here? Many regulated organizations must adhere to strict data protection and AI-specific regulations. Why build custom? Because custom models allow for deep, end-to-end control over the entire pipeline, from data curation and training procedures to bias mitigation and explainability. When compliance mandates require transparent evaluation life cycles, custom guardrails, or guarantees that data remains within specific sovereign regions, pre-built models may not provide sufficient assurances. By building a custom model, you maintain complete authority over how data is processed, stored, and evaluated, ensuring alignment with organizational and legal mandates. This architectural diagram displays the security and compliance boundaries inherent in a custom model deployment. The custom AI model sits securely at the center, fully enclosed within an enterprise compliance boundary. Surrounding it are the critical governance pillars: data sovereignty ensuring regional compliance, transparent evaluation enabling full auditability, and custom guardrails protecting inputs and outputs. Unlike multi-tenant SaaS models, this architecture guarantees that proprietary training data and operational telemetry never leave the organization's controlled environment, satisfying the most stringent regulatory and legal requirements. Moving on to operational economics, we must consider cost efficiency and high-scale scenarios. What does this mean? Sometimes, building a custom model is actually cheaper in the long run. Why? If a model is going to experience extremely high usage volumes, the per-query inference cost of a massive, general-purpose LLM can become prohibitive. How do we solve this? By creating customized small language models, or SLMs, that are highly specialized for a specific task. These models have smaller memory footprints and lower latency. If small cost per query improvements translate into massive enterprise savings and performance gains directly impact revenue, developing a custom, optimized model provides a highly compelling return on investment. This flowchart visualizes the economic decision path for high-scale AI scenarios. It starts with identifying a high-volume inference requirement. We then evaluate the cost. Using a general LLM leads to high per-query costs, which become financially unsustainable at scale. The alternative is to develop a custom small language model, or SLM. The SLM path leads to specialized, lightweight processing, significantly lowering the per-query cost. Over millions of transactions, this optimized architecture delivers massive cost savings, demonstrating how custom models can drive strong financial ROI for enterprise operations. Another advanced trigger for custom models is the need for complex multi-agent systems and reasoning. Basics. Modern AI architectures often deploy multiple collaborating agents, each with distinct roles like planner, researcher, or reviewer. Why custom? Foundation models might lack the specific reasoning behaviors required for these specialized roles. If your business process demands multi-step planning, long horizon tasks, workflow orchestration, or explicit internal memory structures, pre-built models may struggle to maintain context and reliability. How do custom models help? You can train specific models to handle distinct parts of the orchestration, ensuring that your multi-agent ecosystem collaborates flawlessly with predictable reasoning paths. Let us explore this diagram of a custom multi-agent orchestration architecture. In the center is the custom planner model, which has been explicitly trained for workflow routing and task decomposition. It receives the user query and breaks it down, delegating subtasks to specialized custom models, a researcher model for data gathering and a reviewer model for validation. Because these models are custom-built for their specific reasoning tasks, they collaborate with high reliability. This level of intricate, role-based interaction and explicit memory handling is exactly why organizations invest in custom models for complex processes. Finally, let us synthesize this into the build decision framework and readiness assessment. What is this? It is a structured matrix evaluating domain complexity, required accuracy, compliance, and cost tolerance. But identifying the need is only half the battle. How do you assess readiness? Custom model development requires large volumes of high-quality, labeled domain data and robust data governance. Why is this a barrier? Because you also need high talent maturity, including skilled data scientists and MLOps engineers. If your organization lacks this repeatable pipeline for training, evaluation, and deployment, extending Microsoft 365 Copilot is a safer starting point. The decision to build must balance the technical justification with your organization's actual operational readiness. Our final diagram brings all these elements together into the custom model readiness matrix. To successfully build a custom model, an organization must satisfy three core pillars. First, high-quality labeled data must be available and governed. Second, the organization must possess high talent maturity, specifically data scientists and MLOps engineers. Third, there must be a defined ROI justification based on scale, compliance, or accuracy needs. Only when all three of these pillars converge at the center is the organization truly ready to execute a custom model build. If any pillar is weak, the architect should recommend extending existing solutions instead.